Hey guys, today we're going to talk about kinetic energy. Now I'm aware that some of you have already learned about kinetic energy, so this is going to be a review, but some of you haven't seen it in a while or haven't learned it yet, so this might be some new information. The first thing that we need to know is that kinetic energy is the energy of motion. An object must have mass and must be moving in order to have kinetic energy. Now we know that all objects have to have some sort of mass, even if it's teeny tiny, but if they have any mass and are stationary, kinetic energy is no longer present. So it must have mass and it must be moving. And we're going to look at this equation at the bottom. So Ke stands for kinetic energy, and this is measured in joules. M stands for mass, and this is measured in kgs. V stands for velocity, and this is measured in meters per second. So we have Ke equals 1/2 mv squared. Now notice, the only thing that we are squaring is the velocity. We're not squaring the mass and we're not squaring the 1/2. And if you were to rearrange this equation to isolate the velocity, if that's what the question's asking you to solve for, you need to understand that the last step you have to do would be square rooting that velocity. Okay, so we have the equation of 1/2 mv squared. So here we're going to look at two objects. And if both of the objects on the right are moving at 10 meters per second, which has a higher kinetic energy and why? Of these two objects, the higher kinetic energy is going to be the semi-truck. And this is because the mass is going to be so much greater. So since the mass is bigger, its kinetic energy has to be bigger. But it is possible if the two objects could have the same kinetic energy. And this happens if the objects are not moving. So if they're both not moving, their both kinetic energies are going to be 0. But the semi could be moving very slow, and the cart could be moving very fast. Okay, you would have to determine the actual numerical values of the velocity for that to happen, but in order to do the math, we need to have the masses, so it's going to be a little difficult right now without that information. But if the semi is moving super slow, and that shopping cart's moving real fast, then we would be able to have the same kinetic energy. So now we're going to look at one example problem. So we have an African elephant with a mass of 6,000 kilograms. If it has a velocity of 10 meters per second, what is the kinetic energy? So to the right, we're going to list our knowns and unknowns. And our big fat question mark is Ke because that's what the question's asking. So now we have to look for our units. An African elephant with the mass of 6,000 kilograms, we know that goes in for the M. Has a velocity of 10 meters per second, goes in for the V. So then we have Ke equals 1/2 mv squared. Now we're going to take our numerical values and plug them into that equation. So Ke is 1/2 6,000 10 squared. Now in order to make sure we don't have any errors of order of operation, I'm going to do these two things separate. So first, I'm going to do the 1/2 times 6,000, which is 3,000. Then I'm going to do the 10 squared, which is 100. Now I'm going to multiply these two things together, and my kinetic energy is 300,000 joules. Okay, so that was a pretty easy example because all we were doing was solving for kinetic energy and we didn't really have to rearrange. But it's possible that when we return you're going to have to be doing some example problems with this, so I wanted to see this through. Alright, hopefully you have this all in your notes and you don't have any questions. If you do, reach out to one of your teachers and we'll be happy to help you. See you soon.